Make a conference badge. That's right. Let me tell you how this all started. So, a couple of coworkers of mine went to PhreakNIC. I'm sorry, to DEF CON. Actually, a bunch of coworkers of mine went to PhreakNIC. But so my team lead actually went to DEF CON, and he came back with this amazingly cool badge. It had all these puzzles and all this cool stuff on it, and he was like, man, wouldn't it be awesome if we actually made a badge too? And I was like, yeah, that's a great idea. And then he got distracted and went off and actually did real work. This is not a problem I have. So instead, I was like, hey, I want to make a badge too. And then I was like, I'm too little to make a badge because I don't know how to design PCBs. I don't know how to do any of that kind of stuff. But you know what I can do? I can go on the internet and I can buy stuff, right? So I went on the internet, and Adafruit has come up with this $25 board, and it does all kinds of amazing stuff. You will notice it's got these pretty LEDs on it. It also happens to have here. If you see can you see the little tiny eye image there?
I see it.
The tiny eye means that it has a light sensor, and the little like thermometer means that it's also showing it has a temperature sensor. And down here it has a microphone, and over here it has a surprisingly large speaker. In fact, I'm going to pass a couple of these around. Catch. So, whoops. You're gonna get one too, and then you can pass it around. If you look at these boards, you'll see they do a lot of really cool stuff, and it's really easy to just kind of stick a battery on them, and they do neat things, right? So they come with lots of good demos. Some of the other features I did not yet mention is that this chip in the center is an XYZ 3-axis accelerometer, and then you see this little TX and this RX. That is actually infrared send and receive, right? And I'm like, awesome. The things that I liked the most about the DEF CON badge that I saw was that multiple badges would talk to each other and do something cool. And I only got to see one, so I don't actually know what they did together. But I can tell you that it was probably awesome because it was DEF CON, right? Okay, cool. So I'm like, hey, this has send and receive and on infrared. So I said, hey, wouldn't it be awesome? I'm very social, I'm very extroverted. You may have already figured this out. And if you haven't, you know, it's going to happen anyway. So I was like, why don't I make a really cool badge in such a way that like people will have to talk to each other, right? So the idea was, look, I've got like 10 of these LEDs, and why don't I have something that says like, you know, it sends a signal to another badge that someone else is wearing, and then it's going to be like, you've got 10 of these, and so they light up green when you share interests. And then you have to talk to each other to find out what those interests are. Great idea, right? So, 3 to 4 weeks ago, I was like, all right, I'm gonna really start in this now, since I've got the hardware I've got to play with. And I think I'd played with it for like a couple of days, and I was really starting to write code, and then Brimstone here in the back, woo, he said, hey Shay, wouldn't it be cool if they act like fireflies? And I'm like, what? That's kind of what I said. I'm like, what does that mean, right? I don't know what you're talking about. So he's like, let me show you this really cool thing. Whoops, let's try this again. So he's like, hey, look at this cool link. See, you've got these little fireflies, and when you drag your mouse, the fireflies all light up, and when you go down here and click this little button, then what happens is suddenly your fireflies actually synchronize. They're like, oh look, I see the one next to me flash, and then I have to change my clock, and then they all synchronize. And I'm like, okay, sure. So I read the rules in here, and see how they're now all synchronized? So it says here, step 1, when you see a nearby firefly flash, your clock goes forward a little bit, and that's the whole thing. I'm like, psh, I can write code. That seems super easy, right? That didn't work. Totally didn't work. Didn't work for like 4 days, right? Remember, the conference is approaching quickly, and the plan is, okay, in the process, I convinced a lot of people at the Huntsville Makerspace that I was totally going to have code for this badge, right? I was going to have it by the conference. So they bought 10, like 10 people each have one of these. And the pressure's mounting, right? And Hunter over here is like, hey, Shay, you going to write some code? I'm like, sure, as soon as the Firefly thing works, no problem, right? So we had a couple of adventures. My code didn't work. I couldn't figure out why. And I had a couple of really smart people at work who I loaned. I actually bought 6 of these because I really liked them, a lot of fun. So I loaned like 2 of them to one guy, and I loaned 3 to another guy. And they came back and they were like, I don't know, man. I can't even get it to send infrared. Like, it just won't send any signals. So I'm like, that doesn't make any sense. It works fine for me, right? Okay, cool, whatever, sure. So then this turned into things got closer, things got closer. I did more and more. I actually ended up exploring about 12 different rule sets for fireflies. And then of course I got distracted for about 3 days. What about Byzantine fireflies? What if there's a bad actor in the fireflies? How do they synchronize, right? So as soon as I, of course, decided this would be a cool research project, I immediately discovered a paper from 2 years ago where somebody already did that. That's right, 2-year-old paper, Byzantine fireflies is actually a title. I was kind of jealous. Somebody got to it long before I did. Anyway, you should read that paper. It's actually really fascinating and random and confusing, but awesome. Now this entire time, the actual date for the conference is quickly approaching. And so finally, let's see. I don't remember. I'm not really sure how the next thing went, but things really came to a head like yesterday when I showed up. And so Kinsey also worked on the code as well. He was like, hey, this looks easy. I can make this work. And I'm like, good luck, Kinsey, because I've tried like 12 different algorithms and none of them worked. And Kinsey's much smarter than me, so I believe in him. But he's telling me, he's like, no, it doesn't send infrared at all. And I'm like, that doesn't make a lot of sense. And then Hunter is like, no, it doesn't send infrared at all. I'm like, all right, 4 people other than me have tried this code, and they won't actually send infrared. Well, how do you actually tell if it's sending infrared or not, right? Well, there's a cool thing. Turns out that your phone camera is mostly an infrared camera and just happens to be, as a side effect, also a visual camera. So what you can do is you can actually get at your phone camera and you can take a video of this and you can see if it's sending stuff. So we checked, these guys had the boards, they loaded up some code, no infrared being sent whatsoever. Like, that's odd. Doesn't make a lot of sense, right? So, so I tried I took the code that I had written and I loaded it onto their boards and it works fine. I'm like, okay, well maybe their code's a little different. Then I take their code with my computer, load it onto their boards, it works fine. So there's some kind of like, magical realism came into the discussion earlier today in one of the other talks. And it turns out that for some reason, my computer will happily load code that will make infrared go, and no one else's that I can find will do that. That's kind of weird, isn't it? So there's a few lessons that I've actually learned from this. Does anyone have any, if I want to volunteer any lessons I should have learned from this? Because there's quite a few. You, Kinsey, do you have anything you'd like to volunteer?
Learn from Jay how to create the golden tool chain.
Sure, how to create a golden tool chain. I like that. Anyone else want to volunteer lessons learned? You, Brimstone, in the back, trying to ignore this.
Time management.
You know what? Actually, I think that's the first thing, because I feel like I should have started a little earlier, and I should have actually tried to actually not get nerd sniped by this like Firefly idea, because I spent a lot of hours making Fireflies, and it's been a heck of a lot of fun. I mean, come on, look at this. The Fireflies were just this boring yellow. Now they actually light up slowly, and this shows you like their phase and the synchronization. I mean, oh, come on, it's so awesome. It's too bad it doesn't do anything, right? Any other volunteers from the audience want to come up with like tips, tricks, things that could have gone better?
Make an MVP.
Yeah, actually, that's a good idea. Like, I feel like if I'd actually made a super simple demo that had just kind of sent signals back and forth and changed the timing, that probably would have been a better idea. Instead of like, once I had one that worked, stop there, ship it off to everyone else to play with. And yeah, I think that would have been a good idea. I'm kind of glad I didn't go with the like learn to design PCBs first before the conference, because that never, well, man, I wouldn't have had anything, right? At least I just went and got stuff off the internet. This board's actually really recent. This has been out for like 3 months now, so it's entirely possible that like the software of the libraries is not quite up to what you would expect for production stuff. I did a bunch of Googling for like the error messages we were getting, and nothing. As far as I can tell, nobody's actually been working with the infrared part of this very much at all. It is pretty exciting that I have a $25 board. I was able to like record, like I got like a TV like on and off signal, and I recorded that because there's a button you can hit to record a signal and resend it. And I ran around our office turning off all the TVs. That was a lot of fun. I mean, so it does work, right? It does stuff. It's a surprisingly cool little board. See, like Hunter's wearing one and it works, right? Hunter did a bunch of really cool code. He made a fidget spinner, so like if it's flat, the accelerometer will actually be a fidget spinner, and then when you turn it upright, it's actually then a Firefly again. Which, I mean, like there's all this cool creativity. I feel like maybe I should have tried to really collaborate, more time management, more minimum viable product, implement one feature and have that in a separate sketch. Probably would have helped better. I don't know. I mean, that's kind of where a lot of this went. Did I leave anything out of my notes? Yeah, no. I think that's pretty much like all I can think of at the time. Is there any questions, any thoughts, any comments? This is not an hour-long talk. Gosh, we're like 15 minutes in. Did I talk way too fast? Has anyone here actually built a conference badge or had anything to do with one? No? Nobody? You?
Question.
Yes.
A couple years ago, they used to have, the smart boards that they have in schools.
Oh, yes, yes, I've seen them.
So it's like a whiteboard that's computerized, so you can write on with those, one of the old gaming systems used infrared. I want to say it was like a GameCube or something like that with their controllers. I know there was a way you could jerry-rig that thing inexpensively to work on the smart board. I wonder if the phones would do the same.
I don't know. I know. That's actually a good question. I'm not really sure.
It's infrared.
Yeah.
Also, some phones can send infrared, and if you had one of those phones, then you could use it for remotely controlling something to switch what mode it was operating in.
Yeah. Yeah, that would work. There's an example sketch that comes with the board, and also from Adafruit comes this tiny little remote. This is basically a TV remote, right? And it's called like the Adafruit mini remote. And so like one of these basic example sketches, it just has like a big case. Like I can show you what the code looks like. It's actually pretty neat. Yeah, so this is like the latest code that we have in like the repository, and does a bunch of really neat stuff. Let's see, where's like my super simple one? Yeah, so this is like the simple one that I ended up with at the end, at kind of the end of this process, and it really doesn't do much. It's show a pattern, and that this actually just checks the phase. Since there's 10 of these neopixels in here, it counts up to 10. Whichever one is the current number, it flashes that red. That's what's happening here. Then it's we have like you'll see that like the amount of change goes up rather quickly here. That's why it goes from just instead of just being yellow and then off. It actually starts out dim yellow, brighter, 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 brighter. It does it really fast. That's why you get this kind of firefly effect. And it looked okay, but it was really kind of a distraction. And then we have something where they make noises too, right?
Yeah,
Yeah, no, totally. So the idea was that you could tell which phase it was at by which angle the red dot was at. And there was a lot of cool ideas, right? And you'll also see that what I chose as the what I actually chose as the like send firefly signal is actually what you get when you hit button 1 on the remote, because I was just like, whatever, I don't care, I just need some signal. I don't know, like I like to think that maybe some of the patterns would have worked better if I didn't have the magic, my own magic that makes it actually send up infrared. I don't know, it's not a very complicated piece of code.
For the yellow, does it all have is it all like 1 through 10 numbers? Like, can you do individual
Oh yeah,
combinations?
yeah. Each of these is actually individually set, and so you can see what's actually happening in this lovely loop here. We have people here who can read C, right? Can you read C, Andrew?
Very vaguely.
Very vaguely. All right. So what this actually says is we have a loop where I starts at like 0, and then I counts up to less than 11, so that means 0 to 10.
Right.
And then each time through the loop we add 1 to I. And what ends up happening is that whatever our phase and direction is, that's basically going to say, which one of these, that gets set to red. And it says like what's the number of our neopixel, and then what are the colors, and R, G, and B. So this is just set it to red. So when we actually call the firefly, where's the firefly? Here it is. What that actually does is that says, in this case, we're setting the red and the green, which actually is what the yellow looks like. So yeah, you can set it to whatever you want. In fact, I think the fidget spinner code that Hunter has loaded, you can just randomly switch the fidget spinner colors by holding down one of the buttons. This is really a super cool board because you've got the two buttons in here. You can detect those presses really easily. You have a sliding switch like right here, right above the D7, and that's actually used a lot of times for when you don't want to unplug it, but you want to like put it into sleep mode or something. So a lot of times people will say, when it's slid this way, it actually does stuff. When it's slid the other way, it goes into deep sleep for a second, and then it wakes up and checks the switch and goes back to sleep. I actually tested one of these. I had it in my pocket for a month on deep sleep, where it would wake up every second and check. A month on I think it was using a smaller battery than this. That's pretty good,
So that kind of deep sleep stuff in the current GitHub code is happening if these are face down.
Oh, really?
They go to sleep. Yeah.
Oh, wow. That's really cool. I didn't know that.
So those can all have any color then?
That's correct. And you can change it really, really fast. And they get a lot brighter than this also. One of the things I did was for Halloween, I ended up taking, there's a NeoPixel jewel, it has like 7 little LEDs on it, hooked it up to a Gemma, which is a much smaller version of that, and I had this just blinding eye patch for my pirate costume. And basically people were like, you just have to turn that off, I can't even look in your direction, because it was so bright. So these NeoPixels are very, very bright. These are actually, I think, running at about 3.3. So if you run them at 5 volt, you get a lot of light out of them. These also, because this is the new version of the board that has an actual ARM Cortex on it, you can happily run CircuitPython on these directly, which means you get about 150 lines of Python, roughly, and then you just drop your Python file in there and it runs. It's pretty awesome. These also run Mbed, which is kind of a Microsoft sponsored. You have a kind of a Scratch design. Anybody used Scratch or Snappy or any of those things? The drag and drop, the pluggy kind of Lego logic stuff. Super easy. And I honestly prefer writing C just because of the fact that I can do a lot more. Drag and drop takes a long time for me. Any questions, thoughts, or comments? I don't want to completely waste everybody's time here.
Are those 14 pads inputs and outputs?
That's an excellent point. It turns out that if you look at these, each of these, the 8 of these are actually capacitive touch. One of these is a real full-on digital to analog converter, unlike all the earlier Arduinos, which ended up doing pulse width modulation to get analog, you know. A lot of these, like you can see that like we have ground, we've got 3.3 volts, V out, which is whatever you get directly from the battery, and ground over here. This also supports SPI, I2C, like a pile of different, yes?
Do they support charging the battery they're connected to?
They do not, and there's a really good reason for that. It turns out that SparkFun made a kind of a similar board that did support charging the battery, but that necessarily required that it only used LiPo. So it turns out the JST2 pins on here, you can use a really wide variety. I think these can handle like 4 to 16 volts on input. And so the wider that you make your input voltage that's allowed, the less you can actually just charge something. So like the SparkFun boards absolutely required that you have like just a LiPo of a very particular flavor. So Innofrit decided it wasn't worth it because this just handles a much wider range of voltages. And we'll take.
I noticed on this one you handed around, is that a cell phone battery that's powered off of?
It's actually just a LiPo. It's just a standard LiPo. I don't know. That's what I've been playing with. I've heard that the graphene batteries are super cool, and that if you need super high power, you can get a lot more power out of graphene. But I've only seen those being used in drones and that kind of stuff. I'm not sure I need that much power at the moment. Yeah. So there's also, at least the previous version of the board also included a hardware serial support. So I was able to hook GPS to one of these and it worked really well. I was able to hook Bluetooth and GPS to one of these. That worked fine, except the fact that my phone didn't want to talk to it. But that wasn't the fault of the hardware. Yeah, I don't know. Any other questions? Yes?
So here's a thought. I'm looking at it and I'm thinking, as a mathematician, I'm thinking like modular arithmetic. So if you were to assign each with one of the 10 dots a prime number, 2, 3, 5, etc. And then let's say there's 10 things that your group has, and they can choose whatever level of each one. You could then multiply them together, take the factors, and have those be the ones that light up. So you could have light up those two and maybe this color and then you'd have this combination, so you could see what each person was.
Where were you last week? I could have put this code in for this, man. No, that's a great idea. I like it. Because then you could actually say something like, yeah, actually, no, that's great. So we could assign like, number 1 is Linux, right? Number 2 is Mac. Number 3 is, QNIX, right? Who runs OS2 these days? Probably nobody. But you know what I'm saying, right? You put your list of operating systems into each of these. You multiply a number, you send it across, you factor it back out and light up those lights. That could be a good way to actually see what you share, what you like or dislike that you share with someone else. The people who had the very first version of these were getting about 9 feet of range. I can consistently get 3 feet of range, so I don't know what they were doing. I don't know. Also, like trying to get these to synchronize is really hard. And I know it should be super easy. They should face each other. Everybody should be happy. I get it to work every once in a while, but I can't tell if I'm just imagining it. I don't even know.
It could be partly a matter of what your background light is with. If your background lighting is producing a fair amount of infrared, it could be washing out the
So that's a possibility, but these actually have a pre-filter. Like one of the things they said was that, so this would be easy to use. They actually, what is it, like 58 kilohertz? There's some particular popular frequency range that all the infrared runs at for like remotes and for
50 to
signals.
55.
What is it?
50 to 55.
50 to 55, that's it. So it's, so whoever was designing this basically put a pre-filter in there, somewhere 50, 55, somewhere in there. And then, like, if you get infrared light at some other frequency, it just drops it entirely. It's filtered out like much earlier because the idea was that this would be easy to use. And that was the idea. So I think that's unlikely, but I have certainly seen that when I hold two of these close to my screen, they can't talk to each other at all. So it seems like there is some support for the signal being drowned out.
How do they measure time?
They're actually counting milliseconds. They have a chip on board. But at least the previous versions, this is the first ARM board that I've actually worked at, but all of the AVR chips before that were known to lose anywhere from like 1 to 5 minutes a day. So their time is not very accurate. And they basically are they have a chip in there, this is their frequency counter and how quickly they can do stuff, and it just counts up, that's it. So there's not like a real-time clock, there's not a lot of the other stuff you would expect on a real computer. But I mean, it's a $25 board. It has a whole bunch of cool stuff for 25 bucks. Any other questions, thoughts, or comments? No, that's it?
Do you have a 4-channel compiler for it?
No. But you could probably get one.
It's ARM.
It's ARM. I'm sure you can compile
There's a
Fortran.
GCC uses for that.
GCC will do Fortran? Okay, sounds like yes. You gonna write some Fortran for it?
Maybe.
Okay. Did we stretch this out to half an hour? Gosh, almost.
Oh, I will mention one other thing.
Yeah.
Are you writing Haskell for it yet?
No, actually, I've been looking into, there is support for it.
I know, this is GCC, but
Well, no, actually, I was saying there's specifically support for outputting,
putting Haskell to the box.
well, actually, what happens is that Haskell actually ends up generating a bunch of C code that's specifically designed for this. If anyone's not aware, I love Haskell. It's amazing. It's the best language ever. Even better than Erlang.
Nothing's better than Erlang.
Whoa. What were you saying, Hunter?
I was gonna say, because this is a Cortex chip, and it's based on some other architecture that Adafruit has used before, Tyler got the soft USB stuff working. Because that USB, all the serial port and everything that you're looking at is all fake. The chip's emulating these USB devices. There's no hardware USB aside from just the electronics. So he was using the web USB framework in Chrome to talk to it. He was
Wow.
driving the LEDs to different color by dragging something around in the browser.
Wow.
So there's a lot you can do with these.
That's a good point.
Completely non-obvious things,
Yeah.
to me anyway.
When I first plugged this in, it unlike any Arduino I've ever had before, it said, hey, you have a mass storage USB device. Here's a folder. It has an index, HTML, and some other stuff. And I was like, what was that?
Right.
And it turns out that you can actually drop the firmware. You can just drag it into this USB mass storage device, reboot the thing, and it will actually just run your program, whatever it is. That's how you get CircuitPython installed. I think that's how you get the embed stuff running as well. It's actually a really, really amazing board. I mean, it's totally worth getting a couple of them for 25 bucks because you could just do an amazing amount of stuff. I kind of wish that the accelerometer also had like the compass. Most of these chips have not only a 3-axis accelerometer, they also include a 3-axis compass. When I've worked with those before, it was a lot of fun to, like I had a scarf that had a bunch of lights on it because I would do like cartwheels and hook it up to the accelerometer. It was super awesome, right? And then when I hooked up to like the compass, I'd be driving over big bridges and watch the color slowly fade from one color to another as I went over a big piece of metal. That was freaking awesome. So I mean, I kind of wish that were there too, but it really does a lot of stuff for 25 bucks.
Does it have serial output so you can be debugging?
Sure, absolutely. And in fact, I don't know if we've actually got that in the code, but actually, I'll pull up some of the examples. So
Mine has lots of serial debugging.
oh, it does?
Yeah.
Okay, I'll go look at your code.
It's spewing.
Spewing?
Yes.
Okay, sure, that works.
There's a define that I have that will make it very, very loud.
So, yeah, there's a lot more stuff going on in Hunter's code.
The other interesting thing is because the serial is fake, like I said, it's a USB device that the board creates in software, you can tell whether the computer is actually looking at it or not. So right now I've got like this heartbeat thing on this one, and it's happening because it knows that it's plugged into my computer. So it's changing its behavior
Well, that's cool.
to give me more debug information.
You just scrolled over some.
Huh?
You just scrolled past.
I did? I didn't see it. I
You
should-
hit Control F. Just touch it.
Is that anything
Easy.
with the temperature?
Not a whole lot.
I haven't looked at that yet, actually.
Yeah, so if you've never written Arduino code before, you have two pieces to an Arduino sketch. You have init, which runs once, or I'm sorry, setup. Setup runs one time when the board actually starts up, and then you have loop that runs over and over and over. That's it. That's all you get. Nothing else. And so, yeah, you can see that actually, let's go. Actually, do I have a cable here, or is it in my bag?
You don't have one handy, I'm using this one.
Okay. Is yours on a cable?
It is.
Okay. Can I just like steal it and display
The whole thing, yeah.
Insert it out.
This is how under
Right, channel. Okay, there we go.
all the pin drop codes.
I don't know. How many pin drop code in there?
That you know of.
So this is running the code that Hunter wrote, and
I think it's gonna give you a lot of output about the orientation it's currently in.
that's fine. It'll be exciting. If we're overwhelmed, we can stop it. So if you've ever done Arduino stuff before, you have this great thing called a serial monitor.
And it's 115, oh, you already have that.
Yeah, I don't know what it's upset about now.
Probably just wait,
Wrong port.
Well, looks like the right port to me. Oh, serial monitor. No.
Yeah.
It's just port busy, it's a different error. It's no strange.
I will say that this new ARM chip I've had a lot of trouble with. It's been very frustrating.
Open the console and reset.
See, look, now it's gone.
Okay.
Like, what the heck, right?
Interesting.
Like, what did it just do?
I'm still playing Wondering about.
So I'm just gonna reboot the whole thing.
Now you're in the bootloader, which is, you're not gonna have it work there probably.
Did you crash it?
Sort of.
If you hit reset, it drops to the bootloader, which is a really handy rescue mechanism.
Yep. You just had the file can pop up.
Okay, it's not doing anything. I don't know, man. But it's totally supposed to. There's been a lot of this I don't know, man, happening. Yeah. But generally what you do is you have like the serial print and this sort of stuff, and you do this debugging output to the console. And I've done like kind of real-ish embedded development before, and it was a huge pain in the ass. It was a massive amount of trouble and work, and I really hated it. And with an Arduino, it's actually pretty straightforward. You just have printf debugging, you know. So you just put your debug messages in there. This is going to come back to you because I didn't get to work. Oh well. Thank you, Benjamin.
How long have you worked with it, Hunter?
Again?
How long have you worked with this?
With this board, as long as Shay has for this project.
A couple weeks then.
Yeah.
Yes, exactly. A couple of weeks.
And so it's nice to, I did a lot of playing with it and not a lot of actual implementation, unfortunately, so.
It's actually funny because it's surprisingly much fun you can do to play with. Because if you go look at like the examples, there is like a pile of fun stuff. Where'd it go? Where's the? Here we go. Input to serial plotter, simple tone. I don't even know what all this stuff does. SPI, USB host. It does a lot of stuff. It's just amazing. One of my favorite tricks is that if you go back and you look at this, what you'll notice is that the light sensor is right next to one of those NeoPixels that does RGB. So there's this super simple tiny piece of code where what it will do is it says, okay, load this piece of code and then take some brightly colored thing and press it directly up against that light sensor and then hit the button. And it will then light up all the lights the same color as that thing. First time I saw that, I'm like, what is this magic? How could it possibly do that? Well, it turns out that what that does is each of these NeoPixels is red and green and blue. So it turns it to full brightness, and then it checks that light sensor right next to the NeoPixel just for red. It does it for green, it does it for blue, and you're going to get 3 different values. And that was how much of these different colors of light were reflected into the light sensor. And so it's actually pretty good. That was just like amazingly fun, right? It's like you've got all these little pieces that you can hook together in kind of unexpected ways. So it's a really fun board. And honestly, I feel like about 6 people at my workplace now know way more about this board than they ever wanted to know because I'd be like, let me show you this cool toy. That happened a lot. Yeah, any other questions or thoughts? Have you decided to buy 2 yet? I'm looking at you, Sliv.
Not yet.
All right, fair enough.
I'm up to 3 or 4.
I know Dickie's going to buy a couple of them. So yeah, this is honestly a really fun board. I don't know what the heck is up with the fact that 4 people other than me have been completely unable to get these guys sending infrared. I have no idea. I just don't know.
We need to compare our library versions after this.
Okay, that works for me. I feel like maybe if I'm going to do a badge, I should actually work on the badge directly and not get nerd sniped by fireflies, brimstone, and yeah, no, that's it. It's basically like better time management, make a minimum viable product, and then ship it up to GitHub as early as possible. Something that actually I can demonstrate works. Because like a lot of the stuff, Hunter was like, "Hey Shay, are you going to do this?" I was like, "Yeah, sure, totally." And then I work on Firefly some more. And then,
You can always say you build a Firefly badge.
huh?
You can always say, well, it's a Firefly badge.
Well, that's fine, except the fireflies don't work. I mean, they flash, but they don't synchronize. You know, because I mean, like, that's what this was basically doing, right? Was like, this is you got the lovely math that this describes, and it says like, it's actually really, this is a really cool piece of code, and I can put a link on. So like one of the things it does is that it actually says you can see the clocks for each of these fireflies, right? And it shows you that. So like if you turn it off and then you kind of like set a bunch of the clocks, they look random again. And as soon as you turn it back on, they immediately start changing their... I ended up digging into the JavaScript behind this because I'm like, why does this work? Why does it not work for me? I don't understand. And I mean, their rule actually appears to be exactly what they describe, and that is, if you see something within a certain range that flashes before you, then you advance your clock slightly, you will flash slightly sooner.
One thing that occurs to me could be if your flash sensor, if your light sensor is seeing mostly its own flash, if you try to synchronize to itself, as it were.
Well, I did actually have that problem early on.
So you might want to put like a little cylindrical shield around the sensor so that it's less likely to see.
Well, the way that the sensor is actually shaped, it very much gives a code. So it's actually pretty hard for it to see itself. I have had it do that when I put it directly on the floor or like a little bit away from something that's slightly reflective, then it sees itself. But it's like this was actually designed correctly. I'm guessing Lady Ada did this, and it's a really good board.
Are you finding time sync?
Huh?
Are you finding any kind of time sync like MPC or?
No, I mean, this is basically just you write the C code, whatever you have loaded is what you get. So you could, I don't even know how you could do a time synchronize like that. But that was certainly one of my questions, was like, if I had a time signal, would this actually work? At the same time, how do fireflies do it? Come on, fireflies don't run NTP. They don't even have that much RAM, right?
They do.
No, they don't. You're making that
It's
up.
really efficient implementation. They have like a gig.
So I also enjoyed the fact that I gave a lightning talk about fireflies, because they're lightning bugs, right? This made me very happy. I thought that was a bright idea. All right, I'm going to stop the puns now. Come on, firefly puns are good.
Does this visualization show you how far their sphere of influence is?
It does not, but it does let you actually adjust that. So one of the things you can see down here is it says like how close does a neighbor have to be. So we'll reset everything, all right? So once you turn on nudge thy neighbor, then how close your neighbor must be. So it has been theorized by some of my highly academic friends that we don't actually have, not only do we not have kind of like a sphere of influence with this, it's much more like a cone. And so maybe you actually would need something different to do fireflies with this. I don't know, maybe that's the case. This has been a lot of, how the heck does this dang algorithm work? Because I don't know. If anyone here has some great ideas, I would love to hear them. Because
A large silvered mirror.
Do what?
A large silvered mirror.
A large silvered mirror. It might help, might actually work.
Hold it over the units.
I don't know. What the code does that I have loaded on these is it says, if you see a flash, there's like time is divided into 10 chunks. If you see a flash in the last 1/10 of the chunk, it's fine, it doesn't matter. And then you actually end up sending a flash as well. And I wonder, like, maybe I should have sent a flash before I actually did the lights. Maybe this has got the timing off. It's a surprisingly complicated problem. And supposedly this simple rule set works, and I mean, this guy got it to work, right? Why is it so hard? What the heck?
Maybe there's something like you have to hit a signal 2 or 3 times, like 2 or 3 writes, 2 or 3 reads.
Well, so we tried something like that. So our approach to that was, if we go and we turn the clocks on, so we can actually show the clocks, then the idea there was, if we get a signal from someone else, adjust halfway to their clock. So that's like, so you're like, okay, I'm at phase 2, so I'm like at 2 o'clock, right? And then I get a signal at phase 4 o'clock. I will then jump halfway there, so I'll jump 1 step forward. Or if I get exactly across, I'll just jump back or forth the right, half the amount. And that way you have kind of this, I'm getting closer the whole time. That didn't work either. Why did it not work? I don't know. Sometimes they would synchronize, sometimes they wouldn't. It's just really, I don't know.
We'll talk after the show.
Yeah?
I'll show you.
All right. I've heard this from about 12 people now. So good luck there, Log.
Just one mall.
Just one log? There's just one log, my mistake. Yeah, so like Theo, one of my coworkers, actually, he pulled up NumPy. He read a bunch of like matrix-based simulations, and he was like, okay, this algorithm will converge in as few as 10 or as many as 20 steps. It didn't converge at all. But like, I don't know, man. So how not to make a conference badge. Start out with an algorithm that you actually believe, trust, and can demonstrate. Do it on time. Time management's good. Share code with your collaborators as soon as possible. Actually work on the task. Don't get distracted. I don't know. That sounds good.
Maybe debug it in another environment. In other words, simulate the lights.
Well, so we did that. We actually pulled up basically a NumPy matrix. Some of the things about a NumPy matrix, though, is that you have perfect knowledge, right? So you have this ability to, you're just calculating a bunch of numbers that represent stuff. Even if you're doing distance-based stuff, all that kind of stuff, it doesn't seem to translate as well to the real world, and I'm not sure why. Yes, Mog is convinced he's going to fix my problems. I hope this is the case. I would love to learn something.
Well, shit, I can fix all your problems. We don't have to stop. He's done
Whoa.
wonders for me. Look at what a fine man Nick is.
Oh yeah.
I used to be 400 pounds.
I'm convinced, absolutely.
I should have taken my trade.
I'm convinced. I'm totally convinced. Let's see. All right. So, holy crap, we've made it almost an entire hour on random stuff about how not to build a conference badge. I can't believe it.
Do I go build a conference badge?
Let's go build a conference badge after this. Holy crap. Now that we know what not to do, let's not do any of those things, all right?
So how many times have you started over?
About 6. Honestly, it's been 6 times where I was kind of like, something's wrong with my code. I'm going to flush the entire thing and rewrite it and use what I had as a kind of a version. So actually, I was doing Hacktoberfest at the same time, and I think half of my 4 PRs were me swearing fiercely in some random language and then pushing a whole new chunk of code. It just didn't work very well though.
I mean,
so,
that's programming.
yeah. The problem is I've been programming professionally for a long time, more than 20 years now. So I'm used to having more success than that. In any because usually I'm like, okay, I'll sit down, I'll figure this out, and I'll make it happen. And this is the first time where it just didn't work at all.
Get used to it.
Happens to a lot of guys.
It'll happen again.
It's really frustrating. I'm used to being able to at least put down some goalposts, slowly narrow kind of my problem and my solution until I actually have something that matches. And in this case, I'm just kind of like, "Whoa." And I got a lot of other people who are like, oh, don't worry, Shay, I'll fix this for you. Load me the hardware for a couple of days, then come back and be like, dude, I don't even know. It's just toast. They were like, I just can't get it to work at all, and I don't even know why. And I'm like, all right, cool.
Were any of these people Mog?
Of course not, because Mog is truly a super genius. And
It's not super genius, it's just a simple problem.
you're not the first person who said that to me.
But I'll be the last.
If you kill me after this, I'll be sad.
No, you won't. You're dead.
Fair enough.
Counterpoint.
Okay then.
Let's do this, Jay, right now.
No, I want to live.
No.
Oh,
Fix the problem. I'll kill you later. I can't be smug to a dead man. That doesn't work.
Fair enough. I assume you'll preserve my life just so you can be smug, if you're right. Just don't kill me if you're wrong, okay? All right, so any other questions or comments, or do you get to go out early and drink alcohol? You have a question or comment?
No.
Oh, you're going for alcohol. All right, in that case, we are gone. I hope everybody had fun. Bye now.